All right. Hello, everybody. Welcome back to the channel. I am here today with three very special guests. Two people from ARK Invest. A lot of you guys know ARK, Sam and Brett. And one person from Mach 33, which is a research firm, Aaron Burnett. And we're here to talk today about space, specifically SpaceX, the valuation around SpaceX that ARK just put out, and the overall philosophy that they have in terms of valuing this company. So I think my audience is going to be really excited about this. We've been following ARK for a very long time. SpaceX is the hottest private stock in the market. And so I think it'll be really cool to dive deeper into basically the valuation and where you see the trajectory of this company going. Brett, Sam, Aaron, thank you guys for being here.
Thank you for having us on.
So let's get started with this first question, high level. I'm going to go through the model and get kind of more nitty gritty with it. But first of all, I guess, how do you guys philosophically think of SpaceX as a company? You guys have it in the ARK Venture portfolios. You guys have been investing in it for a long time. I guess, yeah, let's back up. When did you guys start investing in SpaceX? And then more broadly, how do you think of SpaceX as a company? And then we'll go into the valuation itself. I think, Brett, we'll start with you.
Okay, fine, me. SpaceX, from the inception of ARK, we have followed private and public companies just because we're focused at the technology level first, not the company level. I think Sam did the first work on modeling reusable rockets. And, at the time, SpaceX had this crazy plan to land its rockets. And, if you talk to people in the industry, they said, well, yeah, I mean, it's possible, but you really can't guarantee you're going to be able to land them. You really should just catch a parachute. And the only reason Elon's doing this crazy thing of trying to land them is because you need that technology to land on Mars. Right. And so, and actually, like, when Shotwell at the time said, we think we're going to land, she said like 60% of them or something. She thought that was like achievable. And so then Sam did the work of, well, actually you want to blow up assets because then you get to manufacture more of them so that then you get scale manufacturing benefit. So it's not like an easy, you save money by landing these things because then you produce fewer of them. And so you don't get the scale economics of manufacturing. And it turned out like if they had only landed 60% of them, it was like borderline, but cheaper to land rockets rather than just have them fall into the ocean. As it turns out, they land, 99 point something percent of them. And so that we did that work. Sam, when did you do that work?
That was probably like 2016 era, 2016, 2017 timeframe.
Right. And so, we've been not only following the company, but figuring out the unit economics of the business for a long time. And then, with the venture fund, there's the opportunity to take a deeper dive on well, what is the value of SpaceX? How do we think about the value that it'll accrue, not just over, this year or next year, not just valuing on a price to sales or like, what's marginal cash flow, net of all kinds of costs over the next year, but really over 5 and 10 years, how much value do we think that they're going to accrue? And then Sam, why don't you lay out kind of like the high level flywheel of how SpaceX works?
Sure. And I'll give credit here to Aaron and Mach 33, because obviously we've been doing all of this. And then, Aaron and I've been talking about space for a long time. And Aaron was like, you guys did the Tesla open source model. Mach 33 has been working on their own SpaceX model for a long time. We should do something and open source it because everyone talks about Mars. No one's really put numbers to it. And right. So, Aaron and Mach 33 were really the catalyst to all of us putting effort into it and collaborating and saying, okay, yeah, this is something that should be open sourced so that people can start playing around and discussing what's going on. And, there are, I'd say, similar trends to the early Tesla model that we did, right? In the early days, we did a Tesla flywheel. I think that was in one of our first open source versions where, you sell cars, you get miles, you get better. That makes your self-driving even better. And it's like makes people want to buy the cars. And then that's a great flywheel there. For SpaceX, the flywheel is you start with a pile of money. You turn that pile of money into rockets and satellites. And that goes up into outer space and gives you bandwidth. And that bandwidth in outer space allows people all over the world to pay for it and get internet anywhere. And them paying for it gives you more cash. and then you start the cycle again. And as you do it, one, your service gets way better, and two, you siphon off money towards Mars. And then once you've fully saturated the global internet market, you have a lot of money that you can then invest in colonizing Mars. And so then, what do you do? Well, some satellites are going to come down each year because they only stay up there for, roughly 5 years on average. So you'll make sure that the internet stays up and the constellation is complete. But then with all of that excess capital, you're going to be building rockets that you're going to send to Mars. You're going to be buying Optimi that you'll be stuffing into those rockets. And you'll be buying raw materials that you'll be sending on the rocket as well. And then you're going to launch a ton of stuff to Mars and start building tunnels for people, landing pads. And, then we attribute that book value back to SpaceX.
Right.
But it's an important principle here is like, you don't expect within a reasonable time frame to get any cash back from Mars. As in, Elon's mission is to take the money from Starlink and to build Mars. And so then I think Jim Chanos looked at our model and said, I stopped reading at the line book value of Mars, which I was like, well, that's good because he got through most of the material because that was towards the bottom. And the fact is you're going to send up some, very productive assets and robots, and they're going to begin, laying out landing pads and roads. And for a long time, that'll be it. You're building infrastructure. And so the way you would account for that on a balance sheet is like, hey, I'm investing in this whole. Right. And I just hold it on my balance sheet at the value of the investment of the whole, and it erodes over time. So the whole gets less valuable over time. Right. But at some point, there will be, all things going productively, actual rocket fuel production on Mars. You'll actually be able to service the Earth satellite constellation less expensively from Mars than you will on Earth. So talk about a barrier to entry. Once they build out like the Mars base, then suddenly their cost of servicing Earth satellites will be half of what anybody that doesn't have a Mars base can do, and so kind of like, then they'll further be able to build out the Earth satellite constellation. And then over the long term, you're beginning to bring in resources from asteroids and you become the industrial base for the solar system. So that's like, so the infrastructure you're building doesn't provide you with cash flow immediately, but it provides you with option value against like controlling as much of that opportunity as is possible. And then at a very high level, like Sam described it really elegantly, and it sounds super simple. And we approached it like, well, this won't be so hard, and it's like you layer on a bunch of cost declines. You have to make a lot of kind of judgments about the demand for bandwidth and how do you determine the demand for bandwidth. And the real art in modeling is figuring out how many variables you can take out and still make a meaningful statement. And that reveals kind of like, these are the really meaningful things to focus on. For instance, bandwidth per kilogram of satellite, the turn rate for Starship. And then these are things that are, well, you can make assertions about what's going to go on here. How many people are going to do like a dish on their roof versus just like pay for this via the phone, and what's the price differential? But actually, those are, you can try to make calls on those in advance, but they don't meaningfully kind of at the right level of abstraction give you a sense of how much cash flow per satellite up or per bandwidth gigabit up this business is going to generate that it can pump into kind of Mars operations.
Right. I think that's a very sophisticated high level overview to this, and we'll get more deeper. Aaron, how long have you been following SpaceX, and what was your logic behind the collaboration with ARK as well?
Yeah, so I really started paying attention to SpaceX with the Falcon Heavy took off in 2018. Weirdly enough, I was in Ecuador of all places seeing this happen on a live stream, and it just blew my mind open. And so basically from that moment, it was trying to fixate and think really about space. And that's what, Mach 33 is we're, a frontier tech research-led asset manager. And so we're really thinking about investing in space and things like that. And so, the reason for talking to Sam was I just saw way too many like not really intelligent or very sophisticated models out there that people were just kind of guessing. They didn't know that much about space. We had done our own. Ours was a lot more bottom up, speaking to all the model or all the variables that Brett was mentioning, like having to remove. Like it just became, got out of hand real quick. It's just that let's figure out if we can put our heads together and make this a lot better, and something that can really do a good job of kind of getting the rough range of where this is headed. And then, but at the same time, be absorbable and accessible to kind of not just the everyday investor, but even sophisticated investors, quite frankly, that kind of just don't really appreciate all the details and the difficulty around launching rockets and satellites and all the complications that come involved.
Right. Okay, so let's get into the nitty gritty of this, because I think I saw this like a week ago, and we saw it live on one of my, I think it was market close streams. And we saw the bear case was 1.7 trillion, base is 2.5, bull is 3.1. Company right now is worth 350 billion. In each of these scenarios in the next 5 years, because this is a 2030 enterprise value, it is an incredible return. But obviously, you're going to get a lot of skepticism by people saying, how realistic are these numbers? So I think let's kind of get started from that perspective, and we can take it into all of the other elements of the model logic. I guess, Sam, we'll get started with you. I'll open up this question. Are any of your valuation models, bear, bull, or base, reasonable in a 5-year time span?
Yes. Oh, I mean, consider the source here. We made the model. We made it what we thought is reasonable. And, especially we were working on it for so long, and you go back and forth, and there's so many things you can debate. And it's like, some places you're like, oh, is this too aggressive? Then other places you're like, wow, this is really conservative. And I'm extremely comfortable. And that's also why we do the Monte Carlo, right? The whole part of the thinking of doing the Monte Carlo and open sourcing it is we put it out there because we've done the research and we think it's reasonable based on all of that. We know the reaction is going to be, hey, this isn't reasonable. And so you put it out there and you say, if you want to change the assumptions, go ahead, and you can kind of see how that swings the valuation here.
Right.
And, one of the areas where I'd say we're actually very conservative relative to every single piece of information on the internet, and it's the key variable in the model, is the satellite performance. And so we don't need to we can dive into those details later, but I think there's actually potential improvements beyond what we've forecasted that we're debating that would get us to different numbers. The other thing, where's like another room where there's debate? Yeah, it can touch onto this, which is the demand curve for internet bandwidth. And so we look at this market and we say, okay, you're going to launch, thousands of satellites. Each country has rural population and urban population. Each of them is willing to pay 2% of GNI. And, you have to be competitive with what's out there or better. And so you have to be able to offer them the internet speed that they're currently getting or better. And so that gives us this price elasticity of demand for internet. And right now we're essentially saying that SpaceX is going to dominate this market. And, we feel comfortable with that, given they have a decade lead on every single other person out there. No one else has successfully landed a orbital rocket. Oh, and Brett, you're on mute.
Sorry, can you pause there for a second?
Yeah.
I think that's the most astounding thing about the SpaceX story, is that a decade ago they landed a rocket. And, it's like, it's not like they hid that fact. I mean, as in, we know they landed the rocket because they broadcast it. Right. And you have a lot of other rocket providers out there with deep balance sheets. These guys didn't look at that and say, gosh, they did. I wonder if we can do that. or even like, it's been 10 years. It's almost been longer from SpaceX's start to them landing the rocket, to them landing the rocket, to the next person sending something up into orbit and landing it on its butt. Like, what an indictment of the space services industry up to the date that SpaceX kind of launched. That there is not a single other entity. Like, I assume that, Bezos's enterprise is going to get there. But this is, it goes from, hey, this is kind of a crazy thing to try to do, which I get. I get you looking at somebody else trying to do it and be like, you idiots are going to waste a lot of capital. And then they land it and you have to be like, maybe I should think about this. And then they start landing every single one. Don't you then say, we need to do that thing? I just don't get how broken the industry is, that there is not another credible player a decade later that is landing a rocket, just one. It's insane. It's really like an indictment of almost capitalism, like, or really government-led capitalism. As in, how does SpaceX have such a lead? Like, Aaron, why does SpaceX have such a lead?
Well, I'm sure that's the headline, an indictment of capitalism that comes out of this. But the thought process, I mean, or Blue Origin's probably the closest. They've launched their New Glenn, like capable. They were attempting to try and land it. It didn't land the first time. They were supposed to try and launch several times in the last few months. They haven't yet. It's coming. It's just a matter of when. And that is a significant factor in the whole cost and being able to put things up into orbit, the scale of everything you need to get done. So I think that if you go back to that, like you think about the model in 2030, 5 years is not really a long time. It's a long time in Wall Street investment world, but not a very long time when you're trying to launch and land rockets and build all that infrastructure. And so Blue Origin is probably the closest. There's a couple of others that are going to be trying, but as far as putting the scale of thousands of satellites up that can deliver and compete meaningfully, maybe you're looking at 2030 by the time there's actually starting to be meaningful competition doing exactly what they're doing. Everything else is more now like, are there other things on the ground that can compete, right? Fixed wireless and stuff like that. Like those are your conversations, because you're not really trying to compare it to an apples to apples comparison. So I think it's all reasonable.
And then on this, right, so then people say, okay, right, we would certainly hope Blue Origin, other players get there. It will make sense. It's like each continent is like talking about it. They want their own constellation for national security. China's probably the fastest follower in terms of space. But then people say, look, Starlink is an amazing business. So if we do it, it will also be an amazing business. And again, this is somewhat of a similarity to the Tesla story, where it's like they made an expensive car and then they brought costs down and made a less expensive car. And everyone said, oh, all of a sudden it's like people want EVs and you can start car companies. And in fact, that was wrong, because then if you were starting a EV company, you had to compete with Tesla, who had already come down the cost curve and was providing a better car for less money. And so then you had all of these other car companies who were like, oh, we're going to do the exact same thing. And they were coming out with $150,000 cars that were not as good as Tesla's $80,000 car. And so then you get a similar dynamic here. Sorry. Go ahead, Aaron.
But one thing that's like, when you take that analogy, then put it on SpaceX, you got like 3 different things that need to be scaled, right? You've got the satellites themselves. They're doing thousands a year, and they'll be able to maintain that or do more. So someone's got to be able to produce thousands of satellites a year. More than likely, there are other solutions, but they're just more complex. So you're looking at thousands of satellites a year. You're looking at millions of the actual terminal units, which they're getting better and better at. Now I think they're producing, multiple millions a year. And then the actual rocket itself, you do have to have enough of them, because they will blow up. You're in a Blue Origin situation, they're not going to be 99% reliable day one. So you got to be able to build these rapidly and be able to have kind of a fleet similar to maybe that Falcon 9 type of fleet that those guys have, that SpaceX has. So it really starts to compound when you think about the lead that they have and the time frame from now until 2030.
Right. Brett, let's get started with this question, because you touched on it on a high level, but I think it's appropriate to go deeper here. Mars. So what is the thesis on SpaceX getting all that cash flow from the Starlink business to then inevitably build the industry that they're trying to build on Mars? And I think the deeper question here is, what if you guys are wrong? What if we can't get to Mars? What if it's too far away? What if Starship doesn't work? Like, does this entire valuation break apart if we can't actually get a rocket onto Mars?
Well, I mean, I think it's producing so much cash flow that you will definitely have a few rockets crash on Mars at the very least. So I don't think there's a question of like getting an object to Mars and having it impact Mars, hopefully softly. I think the to be comfortable with SpaceX, you have to be comfortable with the mission of the business, which is to make human life multiplanetary, and you have to accept the fact that all of your precious cash flow that it's producing is not going to return to you as a shareholder. It's going to go to building up the infrastructure of Mars, whatever that
There's gonna be
looks
no
like.
there's no buybacks. You're not saying?
No, I would be, I'll call it extraordinarily shocked if they bought back stock. Like, I think that there's
Well, but for context, in the most recent round, there were rumors that they did. It's like they are taking care of liquidity for employees who have been there for a long time.
well, sure, but so they provide tender offers at the most
Yeah,
recent valuation to allow employees to get liquid, and there over time, periodically, there have been rumors that, and I think he even alluded to they would float Starlink as a separate enterprise in order to capitalize Mars. Our work suggests that Starlink will produce enough cash flow that you can basically fund Mars without having to capitalize Starlink. And as I described, I do think that there's ultimately kind of like having the Mars base, assuming that it's not all craters of rockets that have failed to land, will provide like a competitive advantage to the Starlink constellation back on Earth and to everything that becomes. So the very, and again, this is like Mach 33 did a lot of work on this is everything you need for like a human habitation on Mars and all the stuff you need to loft up, and and kind of my approach was like, no, we're just going to send robots, and the robots are going to do productive work, and we can't tell beforehand, because they can't tell beforehand what the productive work's going to be. You just ship up robots at a production rate. And in fact, at first, kind of the humans that land on Mars will almost certainly be counterproductive to they'll be productive from the standpoint of like, this is a lot of media attention. So like employee recruiting becomes easier and maybe raising capital becomes easier, but probably not as productive from the standpoint of like, hey, we need to build out like a lot of raw infrastructure before kind of like we're ready for true human habitation here at some point. And you will do it. And maybe you can convince people to sell their house to move to Mars and become colonists and live that hard life to like carve out the new world, literally. And I think that kind of if you think of like the productivity of a human is going to stay roughly flat and the productivity of a robot is going to go like this. And so I think you're going to continue to ship tons of abundant labor out there in order to kind of build up an infrastructure that has some value. And kind of the way we tie the value is like robot production increase per robot like means that they can produce more on the surface. And actually, so as we were doing this work, my revelation was, because I was in kind of like, call it healthy debate with Mach 33 on like, well, how many robots to other material are we going to ship up there? As in, to build a road, would you rather have more robots or like a Caterpillar bulldozer that you're shipping on the rocket?
Right.
As it turns out, like you'd rather have robots. Having abundant labor produces road miles on a weight efficient basis more effectively than even shipping up the specialized equipment. Now, it's not as high a quality a road, but you don't need to worry about rain erosion on Mars. Like there's all kinds of, like you can build out huge capital improvements with just abundant human labor. Look at all of the, like every monumentally large building that you're astounded by on Earth is mostly done with human labor that was extremely inexpensive and no like capital equipment. Think of like the pyramids or St. Peter's Cathedral. And like this is, if you have abundant labor, you can create amazing things. And so then as I was doing that work, I was like, whoa, this actually means these robots will be kind of interestingly useful on Earth. Think of like how expensive housing is to build, because it's all these one-off projects where you're hiring people to frame and, and so then all the modern houses all look the same, like these plain boxes, because that's the most efficient way to do it when you have unpredictable labor that can do this stuff. I think we're going to end up with this explosion in kind of Baroque built environment on the basis of the abundant labor of robots. And that'll partly be driven by the fact that there's a huge demand for the robots in Mars, which is a much harder operational
right. For Brett's thesis, how Mars brought back Baroque architecture.
Yes, exactly. Exactly. I want like St. Peter's, but times 5, one on every continent.
There will be other infrastructure gets thrown up. I mean, you see the little things that SpaceX puts out when they're doing like their Mars updates, and there's like they have to create fuel and things like that, right? So there's infrastructure like machines that go up to be able to pull methane out of the atmosphere. Then you're going to have some machines that to be able to take water, ice, some kind of ice, and turn it into liquid oxygen, because you need that to go back. So those things will exist. But if you're going to build a landing pad, I think to Brett's point, you could take a bunch of shovels with a robot, or you could take maybe some big thing that would level it out. And if you could just work with the robots, it might make sense to do that.
Yeah, and you'll have, I mean, as it's modeled, it's like roughly a third weight robots versus 2/3 other tools, depending on the scenario you choose. And again, that goes back to, it's like somebody could reasonably differ on this and then go in and plug in a different variable. If you need more stuff rather than robots, it'll actually lower the value of Mars over time, because you're basically having to like import things as opposed to create them on the surface, And so that like impacts the valuation. It's not like we have the secret sauce here. I think it's a really good framework for thinking about kind of the like future verse of what SpaceX is going to become.
So this is so this is actually really important to understand. This is contingent on, I'm imagining, Optimus becoming like really useful in the future.
The Mars portion, yes.
Yes, the Mars portion.
Right.
Sam, is Optimus going to become useful in the future?
We believe it will be.
When?
But
when will it become? Will it become useful in time to ship robots to Mars by 2026, maybe 2028?
Yes. Well, and this gets to the interesting thing of robotics. I don't know if we want to go down this rabbit hole.
Let's do it.
But okay, so it's like robotics, interesting market, because it's like doing a full job is extremely difficult, right? Doing 100% of someone's job is an insanely difficult thing that I think everyone talking about robots underestimates. And, this is because people don't appreciate what goes into a job, right? Dishwashers are the perfect example of a extremely successful automation tool that is in every restaurant, in almost every home. And yet, if you look at it, it's like we pay professional human dishwashers more money annually than people spend on buying dishwasher robots.
Right.
It's like, well, why? Right? Isn't that what a dishwasher does? It's like, well, no, that's actually one of like, you look on, there's a website, ONET, which describes every job in different like characteristics. And it's like the job of a professional dishwasher is 1/13 washing dishes. So it's like, okay, right. So this is an interesting task. But at the same time, you take from that, it's like all a robot has to do to be incredibly useful is one thing, and it can proliferate wildly, right? So it's like, if all Optimus can do is shovel, then it could be wildly successful and change we could have a resurgence of Baroque architecture with a single Optimus capable of shoveling times a million, right? So, there's these like single use cases that lead to huge markets. And simultaneously, I think people are totally underappreciating how difficult it is to replace 100% of a job.
Right. And even on Mars, like I would expect, it's like you will need human support there. Like you're not going to be able to coordinate the fleet of robots perpetually with what's the time delay between comms? Like
8 minutes to 20 minutes, depending on where it is.
So like there's going to be the human infill, but from how productive in terms of like the human is going to be there to make the robots more productive, I think is the right way to think about it. And like that's your tool that like creates these infrastructure changes. And there is no doubt in my mind, you can take the curve of improvement in language models and apply it to a bunch of different domains. And it's just the curve is offset by the x-axis, right? But this stuff is coming in a profound way, and there's plenty of evidence of it. I mean, the most performant model in the world, I guess, arguably, but I think it is the O3 model. They just cut prices by 80%. Not that many months after launching it, and as far as we know about OpenAI's pricing strategy, they're pricing that well because they have figured out a way to optimize running it in a much more efficient way, and it works out to like a you have 50 times cost decline per year, the O1 to the O3 model in language space. And so once you get into the sweet spot of kind of like that performance per cost curve in robotics or in autonomous driving, you're going to end up with these radical performance improvements just on the basis of throwing data and compute at the problem. Could robotic performance be like disappointing on the 2026 timeframe? I would expect that it will.
Yeah.
But there's like a reasonable kind of x-axis translation that suggests by 2030 we're going to have wildly performant robots that are commercializable, that kind of can do meaningfully performant work on Mars, that it's going to be like a race to manufacture these things and sell them in. And so if that fails, like imagine the robots can't operate, or imagine like they can't get robot condoms on to protect them from the dust on Mars, I think that would significantly impair our ability to like build out Mars. You'd be stuck with like humans up there with their, giant spacesuit condoms on, kind of like wallowing around in the dust. And it would really like that, would extend that out a lot, but I think it's unlikely.
Just to bring this kind of full circle, the first question was like, is there a chance that Mars doesn't happen? Of course there is. Like, I think it's like comes back to, do you believe Elon's going to make it happen? Yes or no? I think yes, he's going to spend billions trying to make it happen. That'd be my opinion. And then I think another thing that a lot of people probably take for granted is I would probably be willing to put money, maybe not a ton of money, but I think there's a million people today that if they knew they weren't going to die, they would go to Mars. And I think that grows as it becomes a thing. Like this is just kind of, there are a subset of humans that will want to take that risk and have a very high agency, want to go build a planet from zero. So they're going. It's just a matter of, can you get enough mass there? And then, can you get the robotics to work? Do you need to do an excavator that's robotic, which I think just launched like this week, or someone was announcing one this week. So it's like, it's going to happen. And, you got the guy that can kind of make sure that billions goes into it, forcing that being the forcing function. I think it's very likely that it happens at some point.
Yeah.
Which
if you're looking
question,
for reasons that this might not happen, there are plenty of, as in, you should think about this as a set of scenarios. It's kind of like, you could imagine a geopolitical set of factors like conflating such that it's in the best interest of some foreign entity to totally pollute the low Earth orbit satellite space in a way that's really destructive to SpaceX. That's possible.
And it gets right. The other question, right? We're talking about Mars. And if you want to go to Mars, Aaron's keeping a list. So you've got his Twitter info right there. Just send him a DM and we'll get him 1 million DMs. It'll be great. But right, one of the bigger questions then too that everyone seems to be asking with every test flight is, it's like, forget will Mars happen? It's like, will Starship happen? Right. And I think to us, all of us believe, yes, it's just a matter of time before they get it right. But if you read a lot of news and people who aren't into space, they say, this might never happen, right? It's like the dream of launching a skyscraper every few hours with turnaround time is a pipe dream, right? So it's like, that's another variable you can play with in the model. But again, it's like this skepticism is kind of what led to the decade lead for SpaceX in the first place.
Right. Well, I was just going to follow up right there, because you guys have been through this before. You've been through this rodeo with Tesla. Everyone's seen Kathy on CNBC in 2017 saying Tesla's going to 4,000. No one believed her. And then Wright's Law, Moore's Law, everything that you guys needed to happen happened. And obviously the stock did what it did. Why do you think a person like Chanos is so skeptical? Like how do you sort of reconcile the sort of value investing skepticism with the creative imagination that one would think is necessary to even think of investing in a company like SpaceX?
Well, one, there's a media optimal strategy that differs from a wealth compounding optimal strategy. And that's part of the real problem in the marketplace. It's part of the reason Elon's had trouble with the public markets, is like, to attract attention, you should be a cynic. To get rich, you should be an optimist. And my understanding of like even forget Chanos, he's short on. I'm not even sure he runs a book anymore, but because it's hard to fight against beta basically. But even long short hedge funds, they get most of their media based on their short positions, even when that's like a fraction of their book. And so the reason to put a short position on is to attract attention rather than to deliver a return. And it's because people, they want to see things conflagrate and blow up. And, it's like human attention, how many headlines did the 787 crash make the others? This is national news, right? How many people died in car accidents on the same day? Many, many more, or maybe it's roughly comparable. I mean, no, probably more. I don't know. Anyway, you can do the math. The point is that like there's kind of a lot of juice in being skeptical from a media kind of optimization perspective, and because of that, because it gets like amplified, then people who are like glancingly pay attention have perceptions that are way off from reality,
Right.
and that's what makes a market. And so I think that in some ways, time is our friend as like somebody looking out over 5 years. It's like Starship has crashed 2 launches in a row. Oh my gosh, my hair is on fire. I can't even imagine you're talking about Mars. Well, actually the willingness to look dumb is also a superpower. And I think Elon has demonstrated that he is willing to look dumb in the short term in order to establish an incredible strategic position over the medium and long term. And the same is true with, with SpaceX, it's like so obviously true. They have a lead and nobody's even close to following them right now, that it's not debatable. But I remember during the Model 3 ramp, challenges, at the same time they're developing the Grasshopper craft, which was the first Starship thing that like lifted up and landed, and it looked like a trash can that lifted off the ground. And then they put a nose cone on it, and he said, "We're making this out of stainless steel." And people were like posting pictures like, "I can't believe he is pulling the wool over people's eyes with this BS. This is such a fraud." Basically, like the stainless steel nose cone was like kind of crinkly. Somebody posts a picture like, "Oh, Elon, like, oh, you are snowing over these poor investors again on this alternate enterprise that's also a fraud." Well, it turns out that the Model 3 and really its predecessor, the Model Y, was the best-selling car ever produced. Okay, and this like Grasshopper thing, though it's yet to consistently land, was the basis of the Starship, which once they are launching it gives them this radical competitive advantage in the diameter of satellites they can put inside it, which leads to the performance they get. That even if at this point somebody finally begins landing rockets on their butt, so they have like a reasonable cost to launch to low Earth orbit. One, like Starship's cost to low Earth orbit will be much better. And 2, the size of the device you can put inside it will be much larger. And so kind of people are going to be behind a decade again. And so, net of it all, it's like, yes, we've been on this bucking bronco before. And actually it's still happening in Tesla land. And it's happening in SpaceX land and in Neuralink land.
Well, Brett, what do you think? If I were to sum it up as, I think it's understanding and trusting Wright's law is a big piece of all of this. And it's like, okay, Wright's law gives you the potential cost decline and here it is for turnaround time. And there it is for satellite performance. But Wright's law states what is possible, not what is guaranteed. And it's like, how do you keep pushing forward Wright's law? Well, that's like Elon and every single person at SpaceX who's working 20-hour days is what's making it possible, right? So it's like it's very clear to us who believe in Wright's law and cost declines, what is possible. But it's very easy to say what is possible and extremely difficult to make that a reality. And Elon has proven time and again, as well as every single person who works at his companies, that they are willing to put in the effort to be on the cutting edge of that. And that makes a huge difference, right? There's people who are in those same industries who they're operating under the same laws of physics and choose not to be at the cutting edge.
Are you
Well,
sure
what
they're under the
exactly-
same laws of physics?
Yeah.
I don't know.
What exactly is Wright's law, and why have Elon's companies been so collaborative with that law, leading to actual profits for the business?
Sure. So Wright's law states that for every cumulative doubling in production, you get a fixed percent cost decline. And what that percent cost decline is changes based on the industry. And so it was originally done by someone who was watching airplanes being built. And he said, let's write down what's going on here. And it's like, oh, and I think the original paper used 3 or 4 data points, right? So it's like not extremely robust from an academic standpoint, and yet incredibly robust. And years later, right, Santa Fe Institute's done it and said, actually, Wright's law is better at forecasting semiconductor improvement than Moore's law.
To give you a sense, you could use the early Model T production values, go from there to saying, okay, what is a similarly horse-powered internal combustion engine vehicle going to cost today in today's dollars, which is the rickshaw in India, and you get within 20%. So you could call the future cost of a technology from 100 years out and get within 20% of the actual value based on the cumulative production.
And so sorry, Aaron, jump in.
I just want to, if you're looking for more traditional signal than, this kind of thing, like Space Force, I'm on the Space Coast in Florida, rockets shake my house. And I love that. But Space Force, there's the Space Force station just approved. They went through the environmental assessment for 79 launches of Starship. And so Space Force and Defense, they're kind of accepting that this is going to happen, and they're worried about what happens when they're launching 79 times a year out of just this one launch pad. So if you talk to people that are far more knowledgeable than myself, like actual rocket scientists, people that are in the industry, I think very few people actually doubt that Starship, for example, is going to work. It's a matter of, do you run out of capital too soon and kind of externalities. They're not doing anything that's breaking the laws of physics. They're doing things. It's just a matter of wanting to do it, pulling it off. And there's a lot of smart people whose job it is to look at risk and the ability for this technology to work, and are starting to make plans for themselves, for defense and different organizations within defense, to actually make plans around this. This is happening for people that are deep in the industry today. Most people will not. There's going to be a handful of people that think they're smarter than Elon because they're, they were an engineer or something, that will try and debate that. But generally speaking, the vast majority of people, they believe it'll happen to people much smarter than myself.
And so then,
I was just going to ask, why do Elon's companies uniquely benefit from Wright's law?
So they don't. Everyone does. So it's a good example is batteries, right? It's when we first, at founding of ARK timeframe, 2014, 2015, it looked, if you were just looking chronologically, like battery costs had stalled. And that's because, it's kind of in the tail end of the iPhone rush, and consumer electronics had, somewhat flattened out. And so there wasn't a huge new driver of battery demand.
Well, actually, the thing that happened is you had batteries going into laptops. The marginal batteries were going into iPhones. And so the battery purchasing per person was actually kind of shrinking, as in you didn't continue expanding the market. And so then on a time basis, it's if you look at the cost decline curve, it was basically and you're like, oh, mature technology, nothing new is going to happen here. All right, go on.
Right. So it's I just joined ARK at the time, and it's okay, figure this out. It's every single forecast out there is okay, batteries are going to stay roughly $300 per kilowatt hour. You can easily do the math. At $300 per kilowatt hour, you need 100 kilowatt hours for a car to go an acceptable distance. These cars are going to be crazy expensive and always be a niche. There's going to be 100,000 EVs sold globally in the year 2020, right? And that was the consensus. But if you look at it from a
actually, the forecast was all the way through 2040. It was like
right, that it was the leveling out.
It was basically like electric vehicles are not a thing. That was the consensus, basically.
Right. But then if you look and you do it, instead of just looking at it based on time, you do it based on Wright's law and the cumulative doubling. It was clear as like, oh, if you invest and keep building like cars, and so then all of a sudden, instead of an individual buying an iPhone, they buy, 100,000 times more batteries, and then you sell even just a decent portion of those, then it's like all of a sudden you get crazy and consistent battery cost declines. And so, it's like, oh, this can easily come down to the price point. And so then there's this like unit economic switching point that unlocks even more demand. And then you keep getting those cost declines. And so what is unique about Elon is his willingness to believe in cost declines. But these cost declines benefit everyone, right? It's like now any automaker out there can buy extremely inexpensive batteries, but being on the cutting edge and pushing that frontier, his willingness to vertically integrate to drive those costs.
Basically, you couldn't without the Model S, you wouldn't have kind of primed the pump on that curve.
Right.
So some brave idiot had to step forward and be like, no, actually, an electric drivetrain is the better drivetrain. These are going to be safer cars. They're going to be more performant. And we can do it with these cylindrical batteries and stitch them all together. And we're going to figure it out. And I'm going to like take capital and I'm going to, it's not just throw capital at the opportunity. I'm going to like put capital at the opportunity with an extremely high leverage, motivated workforce to like scrap its way to making this thing happen. And then once you cross that threshold where suddenly you can sell, 10,000 plus of these cars a year, then suddenly the battery supply chain kind of like delivers you lower cost product. And then you take a left turn with the Model X and the crazy doors that cost as much as a car, though I love the car. It was like probably a bad engineering mistake. But it gets you to the Model 3 and kind of like the next price point, which is a much bigger, market, and the Model Y, which is a much bigger market. And to be honest, like we're still just scratching the surface with kind of electric vehicles, given the number of miles driven that robotaxis will do, and how ubiquitous robotaxis should become, particularly with the cybercab architecture. But
right. So his willingness to vertically integrate and be at the cutting edge and execute. It's like those three things. So it's like other people benefit because it happens across the industry, but they're not there at the exact same time. But it's like there's tons of execution risk as well, right? So it's like there's nothing to say that someone else who tried it wouldn't have tried it and failed, right? So it's like it is a law that everyone can theoretically
but there's
follow.
A whole separate other category of people who aren't actually trying it.
Yeah.
As in like if you look at Wright's law curve across technologies, like the two major fail cases were in rocketry pre-SpaceX and nuclear power.
Right.
And so it's not that Boeing doesn't have smart people, and it's not that, but really the incentive structures at the industry-wide level were so screwed up that it just did not cause like the smart people to be geared towards like actually delivering more efficient unit output,
So I get this question a lot, and I'm curious if you guys have any take on this at all. Tesla has almost 40 billion in cash. You're talking about Optimus as kind of one of the key things that SpaceX could use to get to Mars. Why do you think Tesla doesn't have a stake in SpaceX?
Let's not get. I feel like Elon said it pretty clearly. He's given the goal of getting to Mars. It's like you don't want to get it messy with public markets or other people who can have some type of stake in derailing that mission. So it's like I think for him, that's given that this has been his stated goal for so long. I think that's the thought. Aaron, I know you've got a different thought than us on Starlink being spun out. So I want to hear if you have other thoughts here.
Well, I mean, I don't really know. There's all sorts of, again, externalities that can cause someone to, needing to or wanting to spin something out. But No, I think Sam's right on when you're talking about why Tesla doesn't have a stake in SpaceX. One thing I did want to harken back to, it bears repeating, is like you think about that rights law and then apply it again to those three core things that they're innovating and manufacturing at scale: rockets, terminals, and satellites. This is where it gets really interesting. But I think there still is an opportunity. I think there's a potential that Starlink, I mean, he said it in the past, it's been hinted at. There's a potential that Starlink does get spun out. If it does, I think it's probably post landing on Mars. This is going to happen. A big influx of cash and liquidity in the markets gets invested in Mars at that point. But this is just conjecture. No one really knows, and they don't need to do it.
I would, or at least
choice.
I would suggest that it wouldn't be a function of required capital, but instead there is a degree, and maybe he doesn't appreciate this yet, but a degree of protection that the public markets provide to a company that is so critically important in so many different kind of national security and type areas. As in, like, you want public shareholders in it, like as in the masses in it, because you need congressional support. You need to, there's similarly, like, I think the AI companies are all, I mean, they've stated that they probably will. They also are very capital consumptive, but I suspect that they'll go public, and they'll partly go public because they think that there's, like, it's in their political strategic interest to be public entities rather than private.
Yeah.
Same could be true for SpaceX. For Starlink.
Yeah, I think it's a fair point you made, Sam, as well. I'm thinking of this for the first time today. I mean, if they did buy some SpaceX on Tesla's earnings calls, they would have to kind of talk about that stake, right? And theoretically, give more information to the public than they might not want to give right now. And it kind of does protect them a little bit from just not
the bigger danger for not danger. I mean, imagine, so I know SpaceX has a lot more Bitcoin on the balance sheet than Tesla does. Right. And SpaceX enjoys the benefits of the public markets, I mean, private markets, and kind of, like, call it less volatile, more friendly, cheaper capital, to be honest. You could imagine a scenario where it's like public markets go kind of tapioca-y, and SpaceX keeps churning along, and they have such a low cost of capital that he thinks it's in his best interest to have SpaceX turn around and take a stake in Tesla. And potentially, like, imagine the SpaceX takes Tesla private news cycle. That would be, rather insane. But, if there's, like, a sufficient valuation discrepancy where he's thought, that was in the best interest of Tesla's mission, which I think is probably shifting slightly here. It's still, like, delivering, transitioning the world to sustainable energy, but I think it's more sustainable abundance. I think that there's a reason why.
The other collaboration that I've always thought is the most natural is, it's like, the only way you should be able to create a login account for Starlink is with an X account.
With an X account, yeah.
Right? And then it's like, okay, that's your portal in X and XAI tied, right? So that's just your default. To X has been getting money transfer licenses. So it's like, you've got a global payments rail, but it's not a rail, it's a satellite connection. I think that's a potentially powerful collaboration.
Yes. Yeah, I agree.
Okay, last couple questions for you guys. First of all, thank you for taking the time. Everyone's Twitter is in the description, so you guys can follow Aaron, Brett, and Sam as well. They were very gracious, giving an hour to explain SpaceX. The risk of Elon. So this entire year has been pretty crazy for Elon. Nonetheless, I think the most sort of, like, adamant supporters of Elon would say that, yes, he obviously poses a risk to every business with Doge, all this crazy stuff. But, like, he is the reason people even care about these businesses. He is I think I would argue, greatest entrepreneur of all time. Do you see that as any meaningful risk to SpaceX, or is it, look, we believe in this guy and eventually he's going to get the job done?
Yeah, it's like, no, the risk reward ratio is 100% in the favor, because it's like, you see every other space company that's not Elon led, and you see that there's no cost decline, or that things take long and cost overruns. And so I think that, outside of the box thinking in rocketry and other matters are part of who he is, and that's a innovator.
Yeah.
I would
think
say
there's
that
go on there.
yeah, the bigger risk is if something happens to Elon, God forbid. I think Mars effectively goes kind of off the table at some point. Like I'm not saying that it's there aren't people that want it, and there are definitely people that want it within that organization, but it's a different level of tenacity when you're driving. I think I just saw a tweet said $7.5 billion was invested for Starship over the last several years. That's a different level of tenacity. And the only reason, I mean, they weren't doing Starship because of Starlink. They're doing Starship for Mars, and like there's a benefit for Starlink long term. So I think that's the biggest thing I think of is you got someone who's so driven on that mission. That's what you're buying into if you're buying into SpaceX. So like if something were to happen there, honestly, probably from like a company value perspective, maybe it's like a Tim Cook, Steve Jobs sort of situation where maybe the value to investors actually goes up over that time because they start focusing on returning money, and that might be great from relatively short-term investor perspective. But I do think Mars starts to drift out years, maybe decades, and then all of a sudden it might go off the table. That's I think the most reasonable risk associated with Elon and SpaceX.
Yeah, I think there's more risk in not taking enough risk than is commonly understood. And like Elon is, it's hard to be as powerful and wealthy and still risk seeking. This is not the easy path that he is choosing. Like he could do things much easier for himself. Like it's very clear. And like big company sloth is partly the impact of every single person in that organization gets into that trade-off. It's like, well, I could take incremental risk here to achieve something great, or I can kind of just like coast, and he doesn't let his people coast. And that's why his companies achieve amazing things. And I agree with Aaron, like there's, personal risk to his safety. There's clearly you need like a Tesla battery. There's and kind of like his unique mania is kind of required to drive towards these ultra ambitious missions. And then the other thing I'd add to what Aaron said is like, he's right. Like from a narrow shareholder perspective, you would prefer them not to do Mars.
Right.
You want the cash. You want the cash for something else. I don't need it. I don't need like rocket fuel manufacturer on Mars. I need cash to buy. I don't know what I'm going to buy out there.
Robotaxi,
like a lemon tree. Yeah, a new
Lambo.
Lambo. And part from the beginning, like because he has this maniacal, insane mission, it drives them to produce technology that is useful for Mars, but then wildly overspec'd for the competition on Earth. And so then they end up with, again, like a very large diameter, largest, man-made object ever to like lift off Earth that can go Mach 33. Is that the name? Why the name is Mach 33? And it gives them this competitive advantage that nobody has ever thought to go after because everybody else was designing what's minimum spec we need to do like Earth orbit. And so they end up with this, literally extraterrestrial technology competing against terrestrial ground-bound companies. In many cases, still ground-bound, literally. And it gives them, it's like they're playing on evil mode, and suddenly they go back and play normal mode on Earth, and they are killing everybody. And so kind of the risk to part of, I think, the manifestation of the risk-seeking behavior that he's demonstrating that I would argue is less productive is kind of like, I'm kind of bored with normal mode over here. I'm going to go and try to do a side quest, with the side quest, he blows things up sufficiently that it's like, okay, maybe this is a more interesting kind of return on time.
Oh, I think he literally said that yesterday at the YC demo day. He said Doge was a side quest, then I'm back to technology because I got bored of that, That's a fair point. It's a very, very fair point. Thank you guys for taking your time. This was super awesome. Last final question for all of you. Thank you all for being here. A lot of comments in the chat saying these guys are really passionate about what they do, and you can kind of tell they're oozing with passion. So, Aaron, I'll start with you. What's the coolest part of running a research firm around space. And then Brett and Sam, what's the coolest part about working at ARK?
And this kind of manifests in why we even did this. I think it's being able to actually put out there the fact that, you know, Mars is an actual potentially investably, maybe in over 10, 20 years, viable opportunity. So I get excited about being able to kind of push that narrative, and that's exciting for me.
Brett,
Sam.
what's the coolest part about working at ARK?
I'm deferring to Sam. Sam.
Oh,
Sam,
Sam,
I
what's
get to
the
take it.
coolest part?
I mean, being able to research and invest in the most cutting edge technologies out there. And it's, you know, for me, when I first started, it was like to be able to Google something and nothing shows up because no one's answered it. And then you do the research and then your link is the one that shows up. You're like, whoa, that's cool. You know, AI's ruined that. It's all out there anyway. But no, AI's weakness, still not great at forecasting things. But yes, just being able to really stay intellectually curious.
I would imagine it's more fun
conversations.
than working at some hedge fund. Like, you guys are doing really in-depth research, not just should we go long or short on some random stock, right?
I certainly think I've never worked at a hedge fund, so can't say for sure, but certainly love the academic rigorousness of the work we do. And yeah, it's like conversations like these, working with Aaron and Brett, Kathy, the back and forth challenging of ideas is really the most exciting thing I could imagine doing.
Yeah, I think it's the durability of the information that we generate while being rewarded for constantly learning. And that's like a hard balance, right? Like,
Right.
you have lots of inbounds, and it's like, oh, I need to read this paper, I need to understand this model, I need to understand, you know, and so kind of like having both the permission structure and really the incentive to take that and try to like compress it into information that will have a shelf life of, you know, multiple years. And that's like our most, I'd say, successful work is kind of like doing that kind of thing. Sam's like cost decline model on EVs, you know, I don't know when you built that. It's probably like 8 years old, 7 years old. And it's just like you extend it and it's like hits on this distribution. You know, it's like this amazing forecasting tool that it takes work to construct it. And then you have just like this, almost like you have a little like keyhole into the universe that other people refuse to look through.
No, everyone looks at it and they say, you're an idiot.
Yes, that's even better also, is it's like, I can just wait. Okay. Yes, you know, you can go, but luckily with X, you can go back 5 years ago and look at the people who called you an idiot and be like, ha, yeah, look at me now, buddy.
Yeah, I think the proving people wrong part is definitely a nice little byproduct of doing what you guys do. And quite frankly, it's a creative job. I mean, I know you guys are, you know, reading PhD level papers all day and trying to do a ton of research, imagining AI is accelerating your research workflow, but you've got to be very creative to imagine the things you guys imagine, and then actually put it out there and deal with the criticism and actually defend your work against what everyone else says. All right, cool. Awesome stuff. Brett, Sam, Aaron, thank you all for being here. All their Twitters in the description. I'm sure we'll talk again in the future. And best of luck on SpaceX. We will be following that story over the coming decade, and hopefully we get to Mars.
Thanks for having us on.
Thank you.
I'll see you there.
Thank you, everybody. See you guys later. Bye-bye.